In this video, I'm going to look at using the custom tables for continuous variables or scale variables where we have different summary statistics. We can still merge the tables together in Excel or Word to present everything together, but I would generate them separately in SPSS because we're less likely to get in a mess. So what I'll do first is show you how to change the summary statistics you're getting out. And I'll probably start just by looking at mean and standard deviation because that's a very common one you'll want to use. But I don't think that's how we're actually going to want to summarize either of these variables. So then we'll take a quick look at what these look like and how to make a decision about what to do with them. So if I go back to my custom tables and I'm going to pull out these variables and put in, I don't know what it's going to do with that percentage. We may have to completely reset the table. Okay, it's just deleted it. It's just gone, I can't do a percentage for that variable type. I'm going to ignore it. So by default, it will choose the mean. So let's just try doing the mean and the standard deviation, and then we'll try some others. So if I go to the summary statistics, now it might be helpful to put in the count because there is going to be missing data. Actually, I might go with the valid N. So the valid N will be the ones where they're not missing. And I'm going to put that. Let's do the count as well because I can't actually remember if that does the same thing. So we're going to get out more than we want just to compare the numbers. Will it tell us the missing? I thought I saw there's a missing. So let's also get the missing and see if that looks correct. So the mean, and then what we would have with the mean is the standard deviation. It may give us too many decimal places. That might be something we come back in and change. So apply, close. Now you can see that this table is getting incredibly wide, and I wouldn't actually want all of these in here, but just to take a look at the... So the 323 in first class was our total number. There's a valid 284 observations, meaning that there is 39 missing. Does that sound about right? That sounds about right. 323 for fair, valid N 323, 0 missing. So probably all we want is either the valid N or the missing, and that's your choice which one you report, but you should report something to indicate that you don't have all the observations for this one. I might report the missing, so let's go back into the table and take out the count and the valid N, and we'll just have the missing. So it'll be your choice how you do this. If you have a lot of scale variables that you're summarizing like this, then you may want to come up with a better way to format it. And probably you want the mean with the standard deviation in brackets. So you might need to go through some formatting in Word or Excel, similar to what we did with the counts and the percentages. So I notice that there's no decimal places here. And perhaps we do want a decimal place. So if we go back into the tables, can I do both of them together? There'll be an option to apply to... You can apply to selection and apply to all, which is quite handy. So even if you don't have all of them selected, you can apply to all so that it's all consistent. So it had decided to not have any decimal places. If I want to force it to do one, I can do that here. I could also change that to be SD so that it's all written out for me. And that's looking a bit better. And then all I really need to do is put that in brackets, which I could probably do in the custom tables as well. So if I definitely wanted mean and standard deviation for all of these, for a whole lot of continuous variables, I could do it that way. If I want the median and interquartile range, I could also do that. So I'm going to pull out the mean and the standard deviation. I'm going to put in the median and go to my percentiles, and I'll put in my 25th and my 75th percentile. And I'll just make this a little bit shorter so it doesn't take up so much room. apply to all. Now, these are both really unusual variables. It's possible that I also want the min and the max, which is quite a lot to summarize for any one variable, but I'll leave that alone for now. Hopefully you get the idea that this is how you add extra things into your table, and then you can just do a little bit of extra formatting to get things in brackets. Okay, so I have all my things here. So that's how I would generate the summary statistics. But before I do that, and this is the extra part for checking what kind of summary statistics we want to use. So if you're already confident that you know how to choose summary statistics, you don't need to watch this next bit. I'm just going to look at box plots and histograms. If you're not sure what you want to choose, then we're going to do a little bit of revision. So let's first look at age and fair, and I'm just going to look at them all together. Should I do that? No, there's quite a lot of data. I'll split them up. So the thing with histograms, if I go into Chart Builder, there's not a good option for splitting by categories. We can do this one, but I actually find this really difficult to read. I prefer to see histograms split out onto separate rows. So if let's do age first. And we get this weird thing. So this is for everyone all together, and we can also do it split by split by class. This is why I probably wouldn't want to summarize it this way, because it kind of looks like it's going to be normal, and then this weird things happens. And if we look, that's about age 18. So I think what is happening is we're getting a different pattern because children can't travel by themselves. So I might want to split this into children and adults. Possibly I may even just want to put it in the categories, because this actually looks like a fairly uniform distribution. This is it will be cut off at 18, so I'm not even sure I want to use the mean to summarize it then. I think what I would really want in this case is just to put people into age brackets or age categories. I think this is a case where I don't find the variable to be helpful as a continuous variable. I might want some sensible categories. If I'm interested in survival, then I think possibly I want a few age groups for the children, based on whether or not, let me think about that, whether or not they would be attached to their parents. So I guess you want babies, just look at babies separately, and possibly older teenagers you want to keep separately as well. And that might be where you make a decision about how to use a cutoff for teenagers based on what is appropriate from the time. So historically, I'm not sure that you would really treat, I'm just trying to think what the working age of children was back in the 1920s or the 19 teens. I have a feeling that children of a fairly young age may have been quite independent, like 14 or so. So I don't know if you want to separate them that way, but that's where you need to have a think about what's relevant to this situation, what makes sense, or do we lump all the children together after they're greater than, let's say, 2 years or something. I don't know. That would be a decision you could make, or maybe you just class them as children. The adults, maybe you want to make a decision about whether or not they're of a sort of working, able-bodied age, and you want to treat the elderly separately. So you might not care about the differences between 20 and 40, but you might care about the difference between 60 and, let's say, 80, for example, in terms of survival, whether or not the elderly were able to get off the ship. So those are decisions that you can make based on the context of your particular study. Just to show you how I would split this histogram up by the three categories if I needed to, the classes, sorry. Rather than go through Chart Builder, I would go to Legacy Dialogues and go to Histogram here. And I can see the variable is age, and I want to split by passenger class. And then I get the three. Oh, I wasn't expecting that. So it looks like, I guess it makes more sense. It does make sense that the wealthier class, it looks like they're a bit older, and I wonder if that's just the wealthier older people are more likely to travel. Is that the direction the cause and effect would go? That might need a little bit of thought to explain why it would be. If you're older and not wealthy, are you less likely to travel? I'm not sure. So there might be a difference there. You could investigate that statistically if you wanted to. And we can see the pattern here is certainly looks more pronounced in third class, but we have a lot more data in third class. So there were, where's our numbers? I'll scroll up through all this. So we have a lot more people in third class than we have in the other two classes. So that might be why we can see the patterns a bit more clearly. So you can have a think about what to do with this one. If I do the same thing with fair, we can start looking at how we might treat that one, and it's going to have different problems. So let me put in, so this is the price they paid for the ticket. Now this is one where it's actually, we were expecting the first class passengers to pay more for their tickets, obviously, because they're in first class. The difficulty is it looks like there might be some extreme values and we really can't see them on the histogram. So this is not very well displayed by the histogram, and this is where if I'm looking for outliers, I'm going to want to use a box plot instead. So I'm going to go back to Chart Builder. And I'm going to put in passenger class for my categories and fare here. So these people paid a lot for their ticket. So I don't know if they were scalped, ticket scalped, or is this like a presidential suite, or I don't know. I don't know why their ticket costs so much more than everybody else's. It seems like a lot. £500 in the old money 100 years ago. That must have been a lot of money. So we do have these outliers. So maybe what we're interested in this case is the median ticket price for each of these. So if we go back up to our table, we can probably see the median ticket price was £60 for first class, £15 for second class, and £8 for third class. So because of all those outliers, I would be using the median and the interquartile range, which is the lower part and upper part of this box. So that's the middle 50% of the data. And possibly it would be interesting to report the min and the max in this particular situation. Once you have all those numbers, that's when you can then put them all onto your table in Word. So if you've drawn up the table by hand, you could put them into here. If you're doing it in Excel, then you can combine the tables and just make sure you say exactly what each of your numbers refers to on the left-hand side. And sometimes you'll see it in the table where they might say numbers are counts percent unless otherwise stated. You might see something like that. And then they don't put these in and they just put these ones in. There's a lot of variation. So what you could do is look up a paper in your area and see how they format the tables, find a formatting that you think looks good, and then you could emulate that for your table. Okay, that's quite a long video. I hope there was something interesting in there for you. If you've got any questions about how to summarize your demographic characteristics or other summary statistics, then just put that in the comments below.